So, if you don't know what preons are, I'll tell you in a minute. But for now, I'm just going to tell you about a video I watched. Well, I guess I'll have to tell you now because you won't understand what the heck I'm talking about. Everything, like this pencil right here, other than the stuff inside of it and this eraser, I'll get a better example. This tiny little piece of paper right here that I'm holding is one gigantic molecule. It really is. There's just atoms all around inside of different atoms combining. Actually, it's a bunch of dead cells. I'm ripping the molecules apart. And with this water bottle, other than the water inside of it, and this, and the cap, and this little thing right here, this little white thing right here, this water bottle is a molecule. It's a molecule of just plastic. It's just one giant plastic molecule. And molecules are a bunch of atoms combined by electrons, like sharing each other's electrons. And then the nuclei of atoms are made up of protons and neutrons, which are made up of quarks. And apparently there's a theory of these particles called preons, which make up quarks. Now, there's no particle yet discovered that actually makes up quarks, but this theory about preons I thought was pretty interesting. So I looked up preons on the internet, and I found this picture about ABC preons, whatever. I went to a website, didn't look too interesting. I'm like, really? So then I went to a YouTube channel. It was the exact same people who made, or the exact same person who made the website. Is the exact same person who made the website, and I watched some of his videos. I was like, whoa. His name is 1 second, because it just puts all the pieces together. His name is Delbert Larson. That's his YouTube channel, Delbert Larson. You should go check it out if you're into quantum mechanics. But and all that, but the cool thing about it is that hadrons or hadrons or whatever are little particles, like protons and neutrons are in the family of nucleons, which is a family of baryons, which is a type of meson. I should probably explain. I mean, a type of baryons are a type of hadron or whatever. Hadrons are groups of quarks, up, down, strange, charm, bottom, top. Usually up, down, and strange. Up, down, and strange. There's 3 generations of quarks. The first one is up and down. Second is charm and strange. The third is top and bottom. All you need to know is that it's just 3 different ones, 3 the same, 2 the same, and 1 different one. Any combination of quarks makes up a baryon. And then there's 5 different families of baryons, or baryons. I want to say baryons. I like baryons. There's nucleons, which are protons and neutrons. There's lambda baryons, which Are basically lambda baryons. They're basically nucleons, just instead of having a up quark, it just has like up down strange, up down bottom, up down charm. So it's basically up down and any other one other than that. So they're basically kind of this in the same family, sort of. Then there's sigma baryons, xi baryons, and omega baryons. And then the mesons are quark anti-quark pairs. Now the reason that there are 3 quarks in there is because there's 3 different like things of light. There's green, red, and there's green, red, and blue. Now the 3 there each quark has 3 different colors. There's each quark, like there's a green up quark, a blue up quark. Now they're not legit green, blue, and red. They're not even like paint. If you mix yellow and blue, you get green. No, if you mix the way to get green is already a primary color in light physics. So this is how you get yellow. You mix red and green together and get yellow. It's just get a green light, shine it, and get a red light, and get a yellow light and shine it, and it'll look like white. It'll combine. That's what mesons do. But I'm talking about baryons. Baryons don't have. They're just white. Now there's the 3 quarks have all different colors, and that's how they combine to make that's how they combine to make hadron groups. Now, how mesons are hadrons is because they combine with their anti-color to form white light. Because green and purple are colors, and they can form white. Red and cyan are anti-colors, and then blue and yellow are anti-colors, so they could form to make white. But that's pretty much all that's talking about. Now the thing with these preons, these ABC preons, is that it explains the hadrons and all that. Now supposedly preons make up quarks, but it says that preons also make up hadrons. And I'm like, what the frick? So I looked up the video on where it explained designing hadrons and all that, and it said that quarks and this is what I found out. It said that quarks are it said that quarks are a C preon and an A preon. Well, part of a C preon and an A preon. So, and then they're bounded by a bond of electron neutrinos. Well, it just said neutrinos, but this is how I figured out how it's specifically electron neutrino. And then down quarks are the same thing except a B a B a B instead of an A. And then charm and strange are the same thing as that. Charm is the one with an A, strange is the one with the B, except it's muon neutrinos, and then so on with the second one as tau neutrinos. The next one is with tau neutrino bond. Now, the reason I figured that out is electron, muon, and taus, those are leptons that it said are A and B with a bond of neutrinos, and it said that the electron, it would be the first stage, the muon would be the second stage, and the tau would be the third stage. So I was like, then it has to be the electron is with the electron neutrino, muon with the muon neutrino, and tau with the tau neutrino bond. That would make perfect sense. So I was like, then that's how the quarks, it said that the up and down are first stage. It said that the first generation is first stage, second generation is second stage, and the third generation is third stage. So judging on what it explained with the leptons, I figured out what neutrino it needed to bond the A and the part of the C together to make them different, the different flavors of the quarks. And now, since that is part of the C, there can be, I like to say it's not just part of the C, like a third, because if you combined mesons are different. Mesons, I'll talk about hadrons in a minute. So these, what was I talking about? I was talking about oh yeah, so I like to think of it as receptors, because if you get a hadron, it explained that it was a C in the middle, and then one quark over here, another quark over here, and another quark over here, or down here. And it'd be like kind of like a triangle. And I remember in a Veritasium video, what was it called? Veritasium, it's like, I really forget what it's called. I know it's not empty space is not empty, but it explains that gluon, people used to think that gluons are the stuff that hold quarks and hadrons together. But what that theory said was that it was the neutrino bonds that held it together. It was like, it would be one quark over here, one quark down here, and one quark over there, or whatever. And then it would be, everybody thinks it would be like that, like they would be gluon springs. Gluon, like one quark, another quark, and another quark, and then gluon springs right here. But that's not how it is. That's not how it is, because it doesn't go like that, because it all like brings it towards the center, because it's a strong nuclear force and it brings stuff together. So that would be weird if it was a triangle bringing stuff to the center. Now, in these, in the Veritasium video, it said, the video is mass does not come from the Higgs boson. That's the video I watched, and it said that in the, well, that's wrong right there. But anyway, it explained that they go like this. It goes like this. Now, what the video said is that how hadrons are made would be like this is how he did a proton. That's what a proton would look like in this Preon theory, because it would be the top, the up quark, another up quark here, so up quark and another up quark down here and a down quark. Now that's a proton, but Veritasium said that the proton looks like that. Don't they look very frickin' similar? Don't they look really similar? I mean, that's incredibly similar. So, and in the gluon flux tubes, I learned in the Veritasium video, that's where empty space truly is, because all around here, and in this stuff, like outside of the gluon flux tubes, is all gluon quark plasma, where it's just a bunch of crazy crap going on. And it said a meson would be here's the example. I'm drawing the example of a pion, which is a meson formed by an up quark and an anti-down quark. It's a negative pion. And I'm drawing big circles around where the quarks would be. So here's the up quark and the anti-down quark. See the little symbols for the anti? And the flux tube, they said, would be in the middle. Now, oh wait, I forgot to draw. And now there's two, actually, I think the flux tubes would go around, the gluons would go around these, like go around like in spirals. Well, let me go back to here, because it said that, because it said the gluons would create flux tubes, which are true vacuums. But I think it's a gluon flux tube with a electron neutrinos going through it or whatever. Because if it was just electron neutrinos, that wouldn't hold it together. That is this, it's giving it the property. It's not like totally bonding it together. It is the bond, but it's the like type of bond. It's the property of the bond. And I think the gluons are just the thing that's holding it together, and the neutrinos are the thing that's giving it the property and actually like making each hadron a unique hadron. And with this one, the flux tubes would go right here, and these would just be inside of the quarks. I drew what a proton would look like going all the way down to the preons. I'm gonna put it right here. I drew what, oh no, I didn't draw what a proton would look like. I already have that here. I drew what a helium atom would look like. So you see here, I drew a diagram of a hadron, specifically a proton, and then I drew a meson, specifically an anti. Oh, never mind. That was a negative pion. I mean, a positive pion. That was a positive pion. And here I drew a big fat helium atom. You can see the two electrons coming around with photon bonds. And it said that it said that the hadrons have it, and then have that there, like the C preon, and then the A and or B preons orbiting it. And I don't think that's right. I don't think it orbits them, like not orbits them, like goes around like an electron does with a photon bond. Yes, that is how the electrons stay with the photons, because photons are the electromagnetic force. But I think that with inside of a hadron, it's, cause when I said the receptors, I meant it was like different colored receptors going together to form the C. I think that when the C can kind of spin around, and then it's like a triangular bicycle wheel, like going like that, like inside of the hadron. And then if you do it down to the quarks, it's just three balls connected together spinning around. So it makes a lot of sense. It really does. This preon theory, I have no doubt in my mind that this is wrong. It is just so simple. It like connects all the pieces together. And if you're like a physicist or something, so if you're like into this stuff, you can go to that channel and Veritas and look at that video. I think because the gluons hold it together. Photons don't hold anything together. They're just magnets. So I don't think that hadrons are subatomic atoms. I think that they are a different type of. They're obviously, they're just a C preon with, they're basically what I just said. Now mesons are, I don't think they spin. I think they just stay there. I mean, these two things could like go like fold like that and in and out like that. But I don't know. No, they can't do that. They just go around like that, and they do. But really, I think that these things just go like that, because it's the Veritasium video said that it like separates. The flux tubes get longer, like stretch, and the video, what was it called? It was the video on the Quantum Dynamics by Fermilab, channel called Fermilab. The dude said the dude talked about different. I mean, the dude talked about it was the quantum chromodynamics video, quantum chromodynamics, and all that said is it was just saying that gluons have color charge too, and that's how they're keeping everything together. And it's like a rubber band. If you stretch it far and far, it'll snap, and with that, it'll eventually snap. If you shoot a photon at the hadron, a quark will try and come off of it, and then it'll eventually snap off and create an quark anti-quark pair, and that's how that happened. And then I watched his video, so that is really cool. You can research it yourself if you're into that stuff. It's a really cool concept, the ABC Preon theory, and it talked about the ABC Preon theory thing. It talked about a fourth stage, and I was like, well, that would have to have another bond, and I said it was the exactly. I came up with my own theory about what that would look like. It would be the same thing, but just with something I like to call. I made it up myself. It's something I like to call a delton, because delta is the fourth letter in the Greek alphabet, and there's already a delta. That's this capital delta. There's already a symbol for that. There's already meaning for that symbol, but there's not a meaning for this symbol, which is lowercase delta. It might be all backwards to you, but I don't know. This is lowercase delta. And I chose that symbol for the delton because it would be the fourth stage, and there's a theory about this fourth generation of quarks. I would think that would have a delton bond in it, in the quarks, but it said that it would be like the symbols for them, because the symbol for up is U, down is D, charm is C, S is strange, T is top, and B is bottom. And then they said that the two other quarks in the fourth generation would be a bilepton, which had the symbol for a T and then a little dash on it, and then trilepton for a B and then a dash over it. And they're quarks, not leptons, and the bilepton has a symbol of a T, and the trilepton has a symbol of a B. Now, Billy, does that make sense? I don't know. I just thought of that. I made up a meme. Now, Billy, does that make sense? At school, like a week ago, and I like to use it when stuff makes no sense, because scientists. I don't know what's so freaking stupid. Like, why would you call a quark? Why would you call a quark with a symbol of a T and a little dash on it a bilepton when it's not a lepton? Because I'm pretty darn sure it was a. You can research that yourself, and maybe I'm wrong that it's called a trilepton instead of another type. But anyway, I came up with the delton thing for the fourth generation or fourth flavor, fourth stage, whatever. Yeah, so So I watched the quantum what's the quantum chromodynamics video by Fermilab, and then I watched the quantum electrodynamics thing from Fermilab, and that basically said that it was very simple. It was just that if two electrons would go by, they would exchange a photon, and that's how they would repel. Like that, they would come closer and repel, but it's not that simple. They come closer and then they exchange a photon and then they repel, because the photon is the particle of electromagnetism, and that's what it needs to create the magnetic thing so it could repel. So, and there's that is he was talking about how you would, that would be like all complex equations. So he said this dude something, I don't even know. Hold on. They're called Feynman diagrams, and they're basically like, the simplest one is that I'll draw it real quick. It's like they get complex equations of electrodynamics, of quantum electrodynamics, and draw it. It's like, that's why he got so famous. This is like about the simplest one. There can be more complicated ones. You can watch Fermilab's video on electrodynamics and the video on the Feynman diagrams, but this is basically what he was talking about. Two electrons would come. The squiggly line is the exchange of a photon, and then they would go, and there's two vertices because that's where they exchange a photon, and then they go off. Now, when he was talking about electrodynamics, he said there could not be the one with three vertices, because if you think about it, if you just create a little electron positron pair right here, that would make four vertices, because the electron would and positron would absorb both of them and emit both of them, so it would get absorbed, switch, and then emitted, and then absorbed. So emitted, absorbed, switch, emit, absorb. So that would be four. And then if it's two, if it doesn't second one, that would be I mean, that's four vertices. If it does another one, that's again four vertices. So he said there was no way to create three vertices. Then I said challenge accepted. So I came up with a theory where there's this phenomena that I don't know what I call it. I labeled it as an imaginary phenomena. Like in mathematics, the I stands for imaginary numbers. Basically, what I drew here is that the electron would go here, and then the electrons would come together and then go off, and then this imaginary phenomena would emit a photon, and these little dots are arrows, not vertices, by the way. Sorry, that's kind of hard to see. And then the imaginary phenomena would emit a photon. Like, these would exchange photons like a normal Feynman diagram, and then this would emit a photon, which would bring it. Or wait, what would that be? A gluon? Would it emit a gluon? Or I guess a gluon would bring it closer. That would make sense. So I guess I'm wrong, kind of wrong there. It would emit an electron. It would go farther away because it would go farther away, like that. It would go farther away like that. Now, if this was a gluon, it would be like a swirly line like this, like that, and then the imagine it would bring this closer because gluon is a strong nuclear force, not the elect. I don't even know what that would do, but that's probably that. Yeah, that's going to be it for this video. I hope you enjoyed my series on preons and my 3 vertices, like my theories on preons and all that, and my explanation on preons. I hope you understood. If you have any questions, please put them in the comments below, and I would be more than happy to answer them, because I love being a teacher and answering y'all's questions. And I hope you enjoyed my imaginary phenomena theory, where it would create a Feynman diagram with 3 vertices in it. The imaginary phenomena is basically like an electron out of nowhere, and just electron out of nowhere. I really don't know how that would happen. I can think about it, and I can and make a video answer. I can make a part 2 and answer all your questions on it. Just feel free to answer. Feel free to answer. Feel free to ask me any questions, and I would be more than happy to answer them. So, hope you enjoyed this video. Hope you learned some stuff. If you're into quantum, the quantum realm, and quantum dynamics, and quantum mechanics. I'm out of breath because I'm talking too much. I will see you in the next live stream or video that I do. So I really have to urinate, so bye.